Hi everyone! Today we are going to be talking about potential and kinetic energy, which is the main part of physics. So make sure that you're writing down a few notes here and there as a reminder for yourself about what we're learning, and you can always let me know if you have any questions. So one of my favorite clips to share when talking about potential and kinetic energy is the Wile E. Coyote video. Let's see if I can get that to work. I don't know if you'll hear it, but at least you can see it. Uh-oh. And that's that for you. So the two forms of energy are potential energy and kinetic energy. Potential energy is stored energy or energy based on position. So one of the easiest forms to talk about is gravitational potential energy, which means because you're raising something up due to gravity, it has potential energy to come back down. Kinetic energy is energy of motion. So waves, electrons, atoms, molecules, substances, anything that's moving. What are some examples? Maybe think of a few ideas where you've seen potential and kinetic energy. We'll go through some together. So some examples of potential energy, like in the video, the coiled spring. So when you push the string or the spring back, it has potential energy to jump back out. Same thing with an archer's bow. When you see him pull the string back, it has potential energy for when he releases it to shoot the arrow. Anything raised up, a raised weight, water being held back by a dam, a quarterback's arm before throwing a pass, a car parked on the top of a hill, hopefully they're using their parking brake, a child at the top of a slide, and a slinky at the top of the stairs. So notice a lot of these examples have some height in them. Some examples of kinetic energy. A baseball thrown by a pitcher, downhill skier on their way down the mountain, a planet rotating around the sun, a moving vehicle, water flowing down a river or waterfall. So anything that's moving. Now there are equations for how to calculate both of these. So when you have kinetic energy, you need to take the mass times velocity squared divided by 2, or 1/2 times the mass and velocity squared. So if we have this example, what is the kinetic energy of a 45 kilogram object moving at 13 meters per second? First, we need to know what is the mass and what is the velocity. So mass we know is measured in grams, kilograms. So we know that that's 45. The velocity is going to be distance in a certain amount of time. So we know that that's 13 meters per second. So now we're going to put it in the formula. 1/2 times the mass, 45 kilograms, times the velocity, 13 meters per second, squared, which gives us 3,800. Oops. 2.5 J Now the J stands for joules. Not joules like jewelry, it's spelled differently, and I think I'll show it in another slide. But that's how we measure energy in joules. Let's do another example. The kinetic energy of a boat is calculated at 52,000 joules. If the boat has a mass of 39,000 kilograms, what is the velocity it is moving at? So now we know the energy and we know the mass, but we don't know the velocity. So we can rearrange the equation to find the velocity. So we know the kinetic energy is 52,000 joules. The mass is 39,000 kilograms. So if we put the information in the equation, we have 52,000 joules equals 1/2 times 39,000 kilograms. We don't know velocity, so we're just using v squared. So we're going to multiply 39,000 times 1/2, which will give us a velocity of 1.63. So we did 1/2 times 39,000 and we did 52,000 divided by that. If you're finding the potential energy of gravity, you're going to take the mass of the object times gravity times height. So how high it is, what's the mass of the object, and gravity. Gravity is always going to represent the same amount. So it's 9.8 N newtons per kilogram on Earth. So whenever you are on Earth, gravity is the same. If you were to go to a different planet, it could change. But right now we're just focusing on Earth. So let's try an example. GPE, gravity, weight times height. When we raise an object off the ground, that's what we're calculating, because gravity plays a factor. So let's look at an example. A 37 Newton object is lifted to a height of 3 meters. What is the potential energy of this object? We have to multiply those things together to get 111 joules. Now, if you look at this roller coaster example here, you can see when it has higher potential energy and when it has higher kinetic energy. As it goes down, potential, kinetic, it goes around and goes through. Potential, kinetic, potential, kinetic. Here's one more example. Potential, kinetic, potential, kinetic. So what you're going to do for your assignment today is you're going to draw a roller coaster that you would enjoy riding on a piece of paper, on the computer, however you want to make it. And after it's done, you're going to label the peaks and valleys showing when it has potential energy and when it has kinetic energy. Now make sure that if you're drawing this on a piece of paper and including a picture, that it's very easy to read and see, so that I can identify when you want potential and when you want kinetic. So that's your assignment for today, and that's all for potential and kinetic energy.